In this video, we will solve simple connection problems with our basic knowledge about normal and shear stresses. In the first problem, we have a connection which is subjected to a tensile force of 5 kilonewtons. The question is, determine the average normal stresses in the rods, rod 1 and rod 2, and in the average shear stress in the pin. The pin is between the two elements. First, start with the first rod. That is a 40 millimeter diameter rod. The force is 5,000 newtons. The area is pi over 4 d square. If we put the values, we get the results in Newton per meter square, and if we convert it to megapascals, the result is 3.98 megapascals. Next, the second rod, 30 millimeter diameter. Well, same force. The diameter changes, and as expected, the stress will increase. The result is 7.07 megapascals. Here we have the pin. Well, if you have the pin, you apply again a 5 kilonewton force to the pin, which is supported by the two sections. Each section is under a load of 2.5 kilonewtons. Well, the area is, as you see, the diameter is 25 millimeters, and that is in meters, and the average shear stress in the pins are 5.09. The second problem is about shear stresses. Here we have a connection of two plates. Well, we have here sheets and bolts in this connection. So the question is, determine the shear stresses in the critical section. What sections are critical? First of all, if you take one side, well, this bolt can shear, and the shear stress in the bolt should be calculated. And another critical section is the areas in the plates. As you see, if this length is not long enough, here it is 100 millimeters, then these sections will be sheared and we will have failure. Let's start with the pins. Well, we know that the load is 9 kilonewtons. So on the left side, we have two pins, and each pin should be sheared along four, let's say, sections. So if you write the equilibrium along this axis, then you have 4 VB shear stress in the bolt. That's the positive, minus 9 kilonewtons. So you have the shear force in each section of the bolt connections. So each section has to carry 2.25 kilonewtons. Well, then we have to calculate the area of this section. We know that the diameter is 6 millimeters. So this is the sectional area in square meters. So if you take the shear force divided by the area, you find the average shear stress in the bolt. That is 79.6. Next critical sections are the sections in the plate. Again, here we have 2 bolts and 4 sections. So for each plate, if you call the shear force Vp, then we have the equilibrium diagram. 4 times Vp, again minus 9, should be 0. Then each of these sections should carry a load 2.25 kilonewton. Well, what we have to do is to calculate the area. We know that was 100 millimeter and the thickness was also 100 millimeter. That is the sectional area, force divided by the area. This is the shear stress, average shear stress in the critical sections of the plate. And overall, well, this is the summary. We have a critical section in the bolt, 79.6 megapascal shear stress, and in the plate we have 225 kilopascal. In our last problem, we have a connection. Well, on the left side of the connection, well, the sheet is glued to a belt, and this belt is connected with the help of a pin to the sheet on the right side. So what is asked? Well, the maximum shear strength of the glued surface, that means, well, we glue a sheet to a belt, and there is a maximum stress which can be carried by this connection, that is 0.75 megapascals. So you have to determine this length so that there will be no failure. And on the right side, you have to determine the diameter of the pin, and the pin material's allowed shear stress is given as 30 megapascals. Okay, let's start. Okay, let's start with the glued surface. As you see, we have here 800 newtons. So the two surfaces, one in the upper, the on the lower surface of the sheet is glued. Each connection should carry half of that 800. So we have to divide 400 to the surface. The width of the surface is how much? 45 millimeters. And dt is the length or the dimension we have to determine. This shear stress should not exceed the allowed shear stress of this connection. So if you solve the equation, you find that the minimum value of dt should be 11.9, so that the surface shear stress will not exceed the allowed value. Next is the pin. As you see, the pin is again forced by two surfaces. Well, if this is the small part, so if we apply 800 over here, 400 and 400, so 400 divided by the cross-sectional area of the pin gives you the average shear stress, which should be less than the allowed shear strength of the stress of the material. The allowed means we have a failure shear strength. If we divide it by the factor of safety, then this is the allowed shear stress. So if you solve this equation, you find that dr, that's the diameter of the pin, should be minimum 4.12. Well, in this video, we have solved 3 simple problems using our basic knowledge of normal and shear stresses. Thank you for listening.